This video is the introduction to research methods. So we're just going to cover some definitions that we need to know before we actually do statistics in this class. So what is statistics? So statistics is the science of conducting studies to collect, organize, summarize, and analyze and draw conclusions from the data. So that's a lot of steps, and only one piece of it has mathematics, and that's when you're actually analyzing. So statistics is not necessarily mathematics. There's actually many mathematicians that don't consider it mathematics. So don't think about this as a math class, because it's definitely not what we're doing. So statistics and psychology, why? Well, you may think I'm not really going to be. One thing is you could be doing research, and to be able to do research, you need to have some understanding of statistics so that you can conduct research experiments and so on, and you can analyze that data. So that's one reason why you would need it. Two, you definitely need to pass this class to get your degree, probably in psychology. Three, it may be you're not going into the research field, but maybe you're going to be a clinician, maybe you're going to do some counseling. You're definitely going to be reading research on counseling so that you are best prepared in your job. And you're going to have to be able to interpret whatever research that you're reading. So it's always going to be to your benefit to understand statistics. I also have this TED Talk that is not actually that long, that tells you why you should love statistics. If not love it, at least tolerate it. I recommend you watch it after this lecture, or you can pause and then just watch that. What is empirical research? So empirical means knowledge observed through observation of events. There has to be some form of measurement. It means that something happened, we measure it, and then that's how we are generating the data that we're going to use. So for the most part, what we do in psychology is empirical research. The idea that it's our job as scientists to figure out whatever phenomenon we're interested in by observing. Samples and population. So this is going to be a concept that's going to haunt you for the whole semester. It's very important that you understand the difference between a sample and a population. So the sample is a subset. In other words, it's a small piece of the population. So here I have this awkward drawing. I have this giant square that has the population that I'm interested in. Obviously, sometimes when I do research, it's going to be impossible for me to reach the whole population. So what I get instead is I get a subset of that population, and that's what I'm going to call the sample. Why wouldn't I always just want to get the population? Well, think about if you're doing survey research and you send out a survey to everyone in the United States. Well, it's going to be difficult to find a mode, whether it's paper survey, telephone survey, online survey. It's going to be hard to find a mode that satisfies everyone because as human subjects, they can always just decline to participate in your study, and then you no longer have the population. It cannot, just maybe not cost effective. It's just too expensive to find the whole population and measure the whole population. Another thing, think of medical research. Would you want me to get the population of your blood cells? That's all your blood. Or would you like me to get a little sample of your blood so I can do my analysis? Definitely you would just want to give me your sample. You wouldn't want to give me all of your blood. So that's a difference. What we're going to do in statistics is that we're going to have a small sample, and ideally we're going to make inferences about what the population looks like based on the sample that we gather. There's many different types of sampling. One of them is called random sampling, and I have this really nice video that I recommend you also watch. I swear they're not long. So random sampling is the method of selecting a sample in which the individuals are randomly selected from the population. Another way of thinking about this is that everyone in the population has the same chance of being selected for your study. That's what random sampling is. Um, Here, what this video is going to tell you is like I have a population of soup. When I take a little spoonful of it, that's going to be my sample. And because I didn't purposely make my spoon take from one side or the other, it's just a random little sample that I got from the population of soup. Um, it used to be really difficult to get random samples numbers. So ideally, you would have a list of the population that would be numbered, and then you would select random numbers to get who was going to be on your sample. In the old days, we would have textbook that would give us the random numbers. Nowadays, you can just go into Excel and ask for a random number, or you can just Google, give me an app or whatever for random numbers, and then you can just select the random numbers, 27, 45, and then you go to the list of your population and you select person 27, person 45, and so on. Random sampling, ideally, if you can have it in your study, it's great. The thing is, for social scientists, we are a lot of the times subjected to ethics. Unfortunately, I'm kidding. So the participant can always decline to not be in our study. So it's difficult to have random sampling when we're working with human subjects. Let's talk about bias sampling. Ideally, that sample that we get from our population, we want it to represent that population. Again, we cannot always get the population, so what we're doing is we're getting a small sample from it, and we're trying to generalize. We're trying to say, oh, from this sample, I know that the population behaves in this way or has this preferences, whatever we're studying. But if the sample that you have, it's not representative of the population, then it's what we would call a bias sample. And it's not necessarily that we did it on purpose. Sometimes it's just, we had a mistake in our sample. So every time we collect a sample from the population, we are subject to sampling error. So I have a population, I take a sample from it, and that's fine. Then I look at the population and I take another sample from it. They're not going to be exactly the same. There's going to be a difference. And there's going to be a difference between those samples that I collected and the population. So those differences is what we're going to call sampling error. So here I have a nice example of bias sample. You can see that in the population, I actually have more females. It's 75% of the females. And somehow I managed to sample this population and I made it 50-50. So this is not accurately representing what the population is. Another big example of bias sampling is the 1948 election where President Truman was elected. There's a very famous, let me see if I can show you. Yeah, so there's this really famous picture of President Truman with the newspaper that says, Dewey, I hope I'm pronouncing that right, defeats Truman. So the newspapers went ahead and published that. They had their newspaper prepare, and then the next day they realized Truman had actually won. So this was caused by bias sampling. At the time, the biggest three pollsters of the day were predicting that Dewey was going to win. But the way they sample the people, they made a strategic mistake. They only sample people that had telephone. So they were serving people by telephone. And at the time, only people with certain socioeconomic status had that commodity of having telephone. So when you're already excluding a certain part of your population, the sample that you get is not going to be representative of the population. So this is something that you can avoid just by having a good design and thinking through what your study is going to look like. Statistics and parameters. So here I want you to think about SNS and PMP. So a statistic is a number that describes the characteristics from the sample, so SNS. A parameter is a number that describes a characteristic of the population, so PMP. Here it doesn't mean a lot to you, but when we start playing with the data, most of the time we're going to have statistics because whatever we calculate from the sample is going to be a statistic. However, we are going to have symbols, usually Greek symbols, and those are going to represent the population. So whatever that Greek symbol is represented is what we're going to call a parameter. So this is important. This is a lingo that I'm going to be throwing out throughout the whole semester. So it's important that you remember it. I don't know, write it on your hand or something like that. It's important. So here I added a couple of questions. In a study of American Airlines flights from JFK to LAX, I should have said Dallas Forward now that I think about it. 48 flights are randomly selected, and the average, the mean, is 8.9 minutes late. The mean is the parameter, or is it a statistic? So this is a sample of flights, is not all of them. So it would actually be a statistic. So the Instituto Federal Electoral, that's kind of like the census in Mexico. Oh, I actually said it here. Says that the total number of housing units in Mexico are this giant number. So are they talking about the population or are they talking about a sample? They're actually talking about the population. So this would be a parameter. I'm going to talk briefly about a couple of types of studies. Not all of them, but the main ones. So a research design is just how your study is constructed. So there are definitely more than the ones that I have here, but these are, this is your introduction, so they should be enough. One common design is an experimental design, and here I have some characteristics. So you need to have what we call random sampling, which I described earlier, or random assignment. So random assignment, again, is when we cannot really do random sampling, but we have a group of people, and by some chance element, we put them into groups. So for example, I could just flip a coin. Heads, you're going into group A. Tails, you're going into group B. And then I flip a coin for every person until I assign them all into their groups. For the experimental design, you need to have 2 or more groups. You can have more groups, definitely. The simplest design and the one that we are probably going to practice with is going to be the experimental design with 2 groups. So one group is going to be the control group, and the other is the experimental or treatment group. So the treatment group is what the name tells you. They're actually receiving the treatment, and that can be a new medicine, it could be a new therapy. We don't really know. Like, they're actually receiving whatever we're trying to test. The control group is only there for comparison's sake. So we are doing something to one group, we're giving them our new medicine, but we need to have something to compare it to. And that's what the control group is going to be. The control group is supposed to have the same experiences for the most part as the treatment group. So that at the end of our study, we can say the only thing that was different between these 2 groups is our treatment. And our treatment is working, or maybe it didn't work, we don't know. But the reason we have that control group is that we can say everything else was the same. The only thing that was different was our treatment. And if it works, then we know it definitely works. Another characteristics of the experimental design is that you have a variable that's being manipulated. And it's being manipulated by the researcher. And it's usually what we would call the independent variable. And I'll talk about this a little bit later. So observational study is when the researcher doesn't manipulate any variables. It's just observing. And then there's correlational studies. The purpose for that one is that we want to see the relationship between two variables. So observational and correlational, they can be, sometimes it's hard to distinguish them. The main point for correlational for me is that you definitely want to see those two variables, a relationship between two variables. And then there's survey research. So survey research is when we send out a survey, and it could be in person that we are, interviewing people. It can be by paper, we mail it out, by phone, or it's online. But it's definitely it can have questionnaires, and then those questionnaires can have what we call liker items. Those items that go from strongly disagree to strongly agree. So that's the kind of survey research. It's not really experimental, and it's not really observational. It's kind of like in the middle. And I know some authors like to call it correlational survey research, because sometimes that's what researchers want to do. They just want to correlate some items or some variables in their surveys. It really varies by author. It's hard to distinguish some of these. And then there's the quasi-experimental design. So quasi kind of tells you it's almost experimental. The variable that's being measured is that it's something that you cannot necessarily randomize, or that you can randomly assign to the groups. And those variables can be something like gender, personality types. I cannot assign that to people. So there's going to be something that I cannot randomly assign in my experiment, and that makes it quasi-experimental. I can still manipulate variables. Let me show you I can still manipulate variables. I can still have two groups, but I'm not going to be able to do the first thing, which was the random sampling or random assignment. This is actually very popular nowadays, and there's new techniques coming out that people are testing. So I'm assuming in a couple of years they're going to be like big. So let's talk about the components of experimental designs, because there's a lot of concepts within that experimental design. So we know it's going to be an experiment when it has random sampling or random assignment. We have at least two groups, the control group and the treatment group. I'm blanking out, sorry. And then I have a variable that's being manipulated. I should have known that, because it's exactly what I'm going to talk about next. So that variable that's being manipulated by the researcher is what we call the independent variable. And you can have more than one independent variable in your study. That's okay. But it's definitely something that the researcher has different levels of. And I'll give you an example in a minute. And then there's the dependent variable. So the dependent variable is what we call the outcome. So we have an independent variable that we are manipulating and has different levels. And whatever those levels if we make our independent variable high, or if we make our independent variable low, that's going to have a consequence, and it's going to be reflected in the dependent variable, in the outcome. So let's talk about this example. I have the effect of intensive summer school college preparatory program compared to no program on the GPAs of at-risk freshman students. So let's talk about first what kind of design this is. I have two groups, people that took the program and people that didn't take the program. So the treatment is probably the people that took the program. The control group is the people that did not take the program. And then I'm going to assume I did random sampling for this, or random assignment. And then the variable that's being manipulated and has levels is actually the college program. So I have the variable, I have the program, that's maybe our high level, and then I have no program. And we can think of no program as being the low level, the 0, and then program being 1. And those are going to be the levels of that independent variable. So let's go into types of variables. Whenever we have data, we can have qualitative or quantitative variables. So the qualitative variables are very easy to spot because they're going to be categories. Then we're going to have quantitative data, and that's going to be numerical data, or it can be rank. There's an order to that data. Once we have quantitative data, we can still split it into discrete or continuous. So discrete is when we have whole numbers, when we count them, countable. When it's continuous, it means that it's something that we measure and that we can split into fractions or decimals. And it sounds very abstract, but I'll give you a couple of examples over here. So a person's height, that would be a quantitative variable. So 6'2", that's it's not a whole number. Qualitative variable for the same concept would be a person is tall or short. Those are categories, and that's going to make a qualitative variable. So here I have a couple of questions. Classification of children in daycare center as infant, toddler, or preschool. So those sound like categories, so I would say qualitative. Number of desks in the classroom. So it's a number, and it would be quantitative because it's going to be a whole number. We're not going to have 1.5 desks. I would say it's going to be discrete. Capacity in gallons of water. So it's not categories, it's definitely a quantitative variable. Now let's see if it's going to be discrete or continuous. So gallons, I could definitely have like 1.5 gallons, a fraction or a decimal. So it's going to be continuous. Brands of cars in the student parking lot. So the brands, I don't know, Toyota, Jeep, that's like the only two I know, Honda. So there's definitely categories to that, and it would be a qualitative variable. The colors of M&Ms, blue, green, yellow, orange, brown, red. So the colors are going to be categories. It's definitely a qualitative variable. Now let's go over continuous and discrete. So again, continuous variable can be measured in fractional amounts, so decimals make sense. At this, a discrete variable is measured in fixed amounts, so we cannot actually split it into fractions. Weights of newborn infants at a local hospital. So I don't know how much newborns weighed, 3.5 kilograms. So my point is that I can have decimals in that, so it would be continuous. Number of loaves of bread baked each day at a local bakery. So yes, I can split the bread, but that's a different question. They're asking for the total number of loaves of bread, so this would be discrete. Number of apps in your smartphone. So that's also going to be discrete because you could not have half an app. That wouldn't make sense. Number of songs you legally download. So that would be discrete as well because it's a whole song. If you were talking maybe about the length of the song and it was like 2 minutes and 45 seconds, you could say it's continuous. Water temperature of saunas at a local health spa. Discrete or continuous. Temperature, I could have 100.5 degrees, so it would be continuous. Lifetime of batteries in laptops. So time is also continuous. Time, weight, temperature, they're always going to be continuous. In this case, time can be years, and then you can cut it into months, and then you can cut it into days, and then you can cut it into hours. So it's always going to be fractions. So it's definitely continuous. Now let's talk about the measurement scales. So there's 4 different types, and I call them measurement scales, but sometimes I refer to them as levels of measurement or scale of measurement. Basically, I'm talking about the same thing. The scales that I'm talking about is the nominal scale, which is basically categories. For example, I have type of music: jazz, rock, blues. And then there's the ordinal scale. So this means there are categories, but there's an order to those categories. My favorite example is the pizza size. There's extra large, large, medium, and small. So those are categories. But the extra large pizza, it's a lot bigger than the small pizza. So even though they're categories, I can see there's an order to those categories. And then there's the interval scale. So the interval scale, you can distinguish it because it does not have, a true 0. The best example I have for interval is temperature. You can actually go below 0. Another example that I've seen psychologists like a lot is the IQ test. You can actually score below the mean of 100, and that's why they call it interval. Then there's the racial scale. So what the a good way to remember ratio is that you're going to have something that we call the true zero. That tells you that the variable can only go from 0 to, I don't know, infinity, to a large number. It's always going to be a positive variable, in other words. Let's go over a couple of examples. Marital status of college students. So what I think of the answer here would be single, married, divorced, never married, that's actually single, widowed. So those are categories, but there's not necessarily an order to the categories. So I would say it's a nominal variable. Salaries of cashiers. So it's not categories, so I can eliminate this too. Now, if I wanted it to be interval, I would have to be a variable that goes below 0. And salary doesn't go below 0. It feels like it, but it doesn't. Then we look at ratio, and ratio is supposed to have what we call, quote unquote, a true 0. So if I'm a cashier, my salary would go from 0 to $100 or whatever. So salary is definitely a ratio variable. Hair color, I don't know, brown, blonde, purple. Those are categories, and there's no order to those categories. Like blonde people are not ranked higher than brunette people. So it's just categories, it's just a nominal variable. Horsepower of motorcycle engine. So the horsepower, when you turn it on, is going to go from 0 to however much horsepower that motorcycle has. So I would say it's definitely ratio. And you're definitely, it's not categories, and it's definitely not a variable that can be negative. I don't think that's possible for horsepower. Your flavor preferences: sweetness, sourness, saltiness, bitterness. So I don't think sweetness is better than sourness. So it could not be ordinal. It's definitely not interval or ratio because it's not really a variable that can be positive or negative. So they're just categories, nominal. Number of tickets sold to an event. So I could sell 0 tickets, but I could not sell minus 10 tickets. It's also not categories. So I'm going to go with the true 0. I can go from 0 to 200 tickets sold. So it's always going to be a positive variable, and that's ratio. I have this other type of variable called Likert scale, and it's not, it's kind of something that's very popularly used in the social sciences. So in statistics is not particular, like if you go to a textbook in statistics, they're probably not going to define it, but I wanted to do it for you because you are in a psychology statistics course. So a Likert scale is named after a guy named Likert, and I'm probably not mispronouncing that, so just be forgiving. It's not necessarily an interval scale, because some people tend to think this would be the 0 point, and then this would be like negative, and this would be the positive side of the scale. We tend to think of it as a quasi-interval scale. They are categories: strongly agree, disagree, neutral, agree, and strongly agree. They are categories because there's definitely a rank to those categories. You can consider it quasi-interval. Some people tend to think of it as ordinal. It's really going to depend on the type of research that you're doing and the things you can get away with. But it's not necessarily a type of variable. It's just something that we use in social sciences because the method of research that we use often is survey research. Last topic, I believe, descriptive and inferential statistics. So descriptive statistics consist of the collection, organization, summarization, and presentation of data. So that sounds easy. In other words, descriptive statistics is whatever we calculate from the sample. examples of this would be calculating the mean, calculating the median, calculating the range, the standard deviation. Maybe I create a nice chart that has frequencies, the frequencies of the observations. Maybe I create a graph. If I'm using data that just represents the sample, it's definitely descriptive statistics. So for the beginning of this class, most of what we're going to be doing, it's going to be descriptive statistics, because we're going to learn how to do the measures of central tendency, which are going to be the mean and the median, and then the measures of variability, which are going to be the range and the standard deviation. And we're going to do a couple of charts. So we're definitely going to be doing descriptives at the beginning of the semester. And then we're going to move on into what we call inferential statistics. So remember when we talked about sample and population, the whole goal of statistics is getting that sample that's representative of the population, and then trying to infer, trying to generalize to what the population thinks. Think about, maybe I take a sample of the university students, and then I ask them questions of what they think of, I don't know, about the dining hall hours. I want whatever opinions they give me on that survey to be representative of the whole university. Otherwise, giving that information to the university president and making decisions off of it, it's not going to be successful. So inferential statistics, the type of methods that we would use to do inferential statistics would be analysis of variance, test of goodness of fit, chi-square tests, basically. And those are going to be topics that we cover at the end of the semester. A couple of questions here. In a recent study on statistical anxiety, 75% of sophomore students who participated in the study had high statistical anxiety. Is this descriptive or inferential? So they're actually talking about that specific sample. 75% of that sample had anxiety. So it's going to be descriptive. If it had said something like all college students experience statistical anxiety, that's generalizing to the population of college students, and it would have been inferential. Then I have this very broad statement: an apple a day keeps the doctor away. So this is generalizing to all people. If I have a very serious condition, medical condition, an apple is not going to keep the doctor away. So it's inferential. Data is plural. The reason I put this is because sometimes people forget that they're supposed to say data were, data are, like it's a plural. A variable is a characteristic or attribute that can assume different values. So here I have what the software that we're going to be using for this class, which is called Jamovi, would look like. So each of these columns would be a variable, and each of these columns can assume a different set of values. So for age, the values that it can assume is numbers. Here we have sex, it has 2 values. Here have ethnicity, I don't know how many values, 7 maybe. The values that a variable can assume is what we call data. The collection of variables is what we call a data set. So here age is actually a continuous variable, and that's why we represent it in Jamovi with the little ruler. Gender and ethnicity would be categorical variables, and that's why we use this little pre-bubble nominal, it's called, variable here. We have another option that's for ordinal variable, and I'll show you when we actually go into Jamovi. There's many types of statistical software. There's SPSS, which is very popular for psychologists and social scientists. There's one that's called Stata, that's more popular with economists. There's SAS, which is ridiculously expensive. There's R, which is a little hard to use, but it's free. And then there's JAS and Jamovi, which are both free. I just prefer Jamovi for other personal reasons. And they both try to simulate what SPSS look like. So if you learn Jamovi now and you have to learn SPSS later in the future, it's going to be very easy for you to pick it up. So here I just have a couple of videos on how to install it, how to navigate it, and how to import data. For the most part, I'm probably going to give you the file in a Jamovi format that you can just open. But I think for the first couple of assignments, you definitely have to import data. So I recommend watching this. You also have to install a couple of modules, and I created a video on showing you how to install those modules. So for example, if we were using SPSS, you would have to pay around $180 to use that software. And then if we had to use a module, specialized module, we would have to pay extra for that module. So here the modules are free. Sometimes they're a little clunky, but you know, that's what we get for what we paid for. It's still a really good software to learn about statistics. I also gave you these activities for you to open Jamovi and start playing with it. Try inputting this data into Jamovi, and then I gave you an extra file that's going to be posted on Canvas for you to learn how to import data into Jamovi. And then this other video is just like the answer key of what it's supposed to look like. You don't really have to submit this. It's just for you to practice. You are going to have a homework, but if you want to start practicing on this, here's an activity that you could be doing.